Hey, good morning. I got several of you that are missing school this week, so I'm glad you're watching my videos to try to keep up here because we got some pretty challenging lessons, and you really want to keep up because this will be really hard for you to catch up on if you're not doing your homework or watching these videos. So today we're going to do rational exponents, and rational means fraction exponents. And so we're going to need a calculator for sure today that has roots on it. And so if you remember back to the beginning of the year when we did square roots like this, or back to junior high days, you should have done square roots like these warm-up problems here. So if you'll do these real quick, I have the answers on the next page. So do these, pause your video, and then come on back and we'll see how you did. Okay, so on these guys, you should have learned, like with the Pythagorean Theorem last year, when you guys did Pythagorean Theorem on triangles, you had something like a squared plus b squared equals c squared. And so then you squared these numbers, and let's just say this was 9, and this, let's just make sure, let's say a was 3, that's how you got 9. And let's just say b was 4. So then you said 4 times 4 is 16, you added 16, you took 9 plus 16, which would be 25, and then you said equals c squared. Well, to get rid of the square, you had to take the square root of both sides. That's how you get rid of a square. That's the opposite of a square. And you said, hey, c equals 5, because the square root of 25 is 5. All right, so kind of here, the square root of x is the number whose square is x. So it's kind of the opposite is what you're getting at there. Probably didn't get that one. I had to think about that one for a little bit. Calculators, if you just typed in what is the square root of 81, you would have gotten 9. But square root really means there's really a little 2 up here. We just don't write it because we just assume there's a 2 up there. But we really said, well, what number times itself 2 times would give me 81? And that would be 9. 9 times 9. So that's what your calculator is really doing in there. We're going to kick it up a notch, and we're going to get other roots other than 2. All right, this guy here, the negative sign's out front, so I know it's going to be a negative answer, and the square root of 25 is 5. The next one is kind of like a fraction. Now, my calculator will spit out an answer. If I did square root of 24, it spits out an answer like that. But I have to know what that calculator did. And here's what the calculator did. Is it split it up into 2 roots, because I know 4 times 6 is 24, and 4 is a perfect square. So then they took the square root of 4 and got 2, and we still had this left over. So our final answer is 2 square root of 6. Okay. Over here, last year you should have learned that we can break these square roots up, that we can put a square root on both sides of this. And so 9, the square root of 9 was 3, and the square root of 49 is 7. Okay, so even though it's one big radical sign, you can break it up into two halves like that. Okay. All right. So hopefully that's a refresher from last year, because you're going to kind of work more with that today. Okay. This is called a radical symbol. That's the technical name for that. And the index is the small part to the left of the radical symbol, which tells us which root. So we call it a root to take. For example, there's a 3 over here now instead of a 2. And so that's called a cube root, or the third root. Okay, so if we were reading this math problem right here, we'd say, what's the cube root of 8? Or what's the third root of 8? And so if we put that into our calculator, which is going to take some practice here, but basically what we're saying is what number times itself 3 times will give me 8. 2 times 2 is 4, times 2 is 8. So our answer is 2. Okay, so just like square roots, this number says, well, what number 3 times now times itself will give you 8. All right. And so here's what's going to happen is we're going to get some fraction roots down here, our fraction exponents down here. And so here's the proof, if you have you, that would explain this. We already said that the opposite of a square root is the square. And so what they're saying is if we took the square of both of these sides right here, we squared both sides, well, this square would cancel out that square root. So if we're going to do this, well, an exponent of an exponent, we multiply it. So then we get a 2k up here as an exponent. This just becomes b to the first. They said, well, let's just focus on our exponents now. And so they just brought that down because our bases are the same. And they said, well, here's 1 and here's my 2 k's. And I said, if we wanted to get the k by itself, well, we would divide both sides by 2. So k equals a half. And so what we're saying here is the square root of b is the same as a half of a b with an exponent. Okay, so let's take it for example here. Let's do, because I know what the square root of 81 is, it's 9. And let's do this. And let's do a half here. Okay, so do you agree? I'm hoping you agree that the square root of 81 is 9. 9 times 9 is 81. Now let's go over to our calculator and let's do 81. So on my calculator, which I think I have one down here, yeah I do. On my calculator, I'm just going to type in 81. So I'll put in the 8, 1, and then I will use my exponent button. And I will say my exponent is a 1 divided by 2, because that's what my fraction is, 1 divided by 2. So try that real quick on your calculator. You'll have to figure out how your fraction's up there if you don't have a green one like mine. So I'm going to do 81, exponent 1 divided by 2. Now my exponent is up there in my little window there. It says 1 divided by 2 and my exponent there. And I hit enter and I get 9 as well. So what I'm kind of seeing a pattern here is that whatever this little denominator is, that is my root. Okay. Now that's going to be important because now things are going to change a little bit. If I say 3 to the half power here, this is really also my root. I can put it out there. And so I could say, what's the square root of 3? Same thing here. I can put the 4 as my radical root here and say, well, what's the fourth root of 5? So whenever I see a number with a fractional exponent, then I'm just going to use that denominator as my root. It's kind of the simple rule here. Okay, we take the base, or whatever the number is that we have there, that goes under the radical sign, and then our root is the denominator. So let's go try a couple. So when you rewrite this one here, we're going to write, there's my denominator, so I'm going to say, okay, I want to know what the third root of 125 is. Now, you could use your calculator and just put, just like we did up above, and say 125, do my exponent, and say 1 divided by 3, and you'd get your answer 5. That's true. And so if I was doing a test or something like that that didn't require any variables or whatever there, that's probably what I would do. But I got to know what my calculator is doing. So let's practice our roots button. So on my calculator, and I'm going to erase this stuff over here, I have a second function button here, and I see right here, let me get my pen here. I see right here, I can put in, it says x square root of, and then just blank down here. So in my calculator, what I need to do is if I want to do this math problem over here, letter A, I have to put in a 3, and then I want to hit my second function button. And you'll see in the window there that it says, okay, that's up here in my root. So a 3 will pop up there in my root. And it'll say, okay, now what do you want underneath the root? So as soon as I hit that button, then I'll type in 125, sorry. Erase that. I don't know what happened to my eraser. I will hit 125. Come on, pen. So really, I want to know what the cube root of 125 is. So I'll hit that second function, 125, and I get 5, just like up there. Now, it's important that we be able to do it this way as well, because pretty soon we're going to get letters in here, and we need to, or we're going to work backwards to get back to this up here. So it's not okay for us just to keep saying, hey, 125 exponent 1 divided by 3 equals 5 and move on to the next problem. We have to look at the pattern here of what we're doing so that we can do some more higher level math here. Okay, so there's my denominator. So this is going to rewrite it as 6 over 64. And then I want to take 25, and I want to know what the square root of 25 is, because again, that goes for my root right there on a fraction. So I know the square root of 25 is 5. I don't even need my calculator for that one. Now I can't remember what the sixth root of 64 is, so I'm going to find it out on my calculator. And that's 2. So 2 plus 5 is 7, so that whole thing right there is 7. Now again, I could put this whole fraction into my calculator. The whole thing, right on across. And if I did it all correctly, it'd spit out 7. But again, don't keep falling into that. You can check your work by doing that, on the calculator quickly. But again, we're going to get to some more challenging problems with variables and things like that. And so we have to know what the calculator is doing. Okay? All right, so you try it. Give it a shot. I have the answers on the next page, so let's see how you do. Okay, let's see how you did. That 4 should have been our root, so the fourth root of 81 would be 3. That's basically saying if I took 3 times 3 times 3 times 3, I'd get back to 81. Okay? Over there on 1b, I put square root of 121. I don't really have to write a 2 there because, again, whoops, I'm not sure what happened there. We don't really have to write a 2 there because we know that square root really means there's a 2 up there. Okay, so a lot of times in math, because it's used so often, we won't write that 2. Fourth root of 256 is 4, and then 11 plus 4 is 15. All right, let's kick it up a notch here. Now, so far we've had the numerator always being a 1. So now we have a little bit of a problem because we have b to the 2/3 is my fraction exponent. And so there's 2 ways that we can solve this problem. And I'll talk about which way I like to do it so that it's fast here in a minute. But I can break this 2/3 down to 2 times a third. 2 times a third is 2/3. And I know with my exponents, if I have an exponent of an exponent, that's the same thing as multiplying. So really, I could say b to the 1/3 times to the second power. Now, this part right here looks like what we've just been doing. They scooted this 3 over here, but they said, okay, when I do the cube root of whatever this number is, b, then I'm going to square it, which would be okay. Now, let's go over to this side over here. Over here, same thing, 2/3. They said 2 times a third is the same as 2/3. And so what they said on this one is, okay, well, let's go down here. If I square the b first, then I would get my answer. And then this looks like a problem like previously. I'd have something like, I don't know, let's just say after I squared it, it's 81. So let's say b was 9. So I squared it. 9 times 9 is 81. But then I want to take a third of that because I still have that third there. And so then this 3 goes over here again. And so then the cube root of 81, which I'm not sure what that is. I'll do it quick here. It's probably going to be a fraction. Yeah, it's a decimal because I just picked a random number. But anyhow, we'd put that cube root over here. Okay? So one theory says let's take the root first and then square whatever that answer is. This one says let's square it first and then take the root. So either way will get us the same answer, and I'll do it both ways one time here, and then you can pick whichever way works for you, and I'll talk about speed and still being accurate. So the first way here said let's take that numerator there and make it into an exponent. So what they're saying here is let's take the cube root, put that down here in the root of 216, and then let's square that, whatever that answer is. So let's get that answer. So what's the cube root of 213? So oops, 216, sorry. I get 6. So this part right here equals 6. So I'm going to do now, bring my 2 down, because I want to square that. And 6 times 6 to the second power, I know is 36. Okay, now let's do it the other way. Now the second way said you could do it this way. Let me refresh my memory what they did up there. Oh, they said let's take 216 and let's square it, because that would be my 2. Sorry. Gotta get back used to doing this. We're going to square it, and then we're going to times it by a third, because 2 times 1/3 would be 2/3. So the 3 goes up there. So now 216 squared is a big number, 46656. But now I want that to the 1/3 root. Well, we learned in example 1, this is my root. So if I take the third cube root of 46656, which is a lot of digits to plug in, 46656, I also get 36. Okay, so I like the first method here because, I can put all this into my calculator and just keep continuing on with my problem. I'll show that with you here. I like the first method where I put this as my root right away. So I take 32 to the 5th power, and then I'm going to take it into the 4th power there. So on my calculator, I'm just going to put a 5 green second function. That's going to give me my square root, 32. I'm going to get that answer, and I'm going to record it and just leave it in my calculator, and I'm going to hit my exponent button and put a 4 in, and it's going to give me my answer. So everything flows nicely on my calculator if I do it this way. I don't have to remember all these big number digits to plug in. So kind of figure out whatever way works best for you. Okay, so I'm going to take the 5th root of 32. And I get 2. So just this amount right here in my calculator is a 2. So I want to leave that 2 in my calculator, but I want to bring down my exponent. So now I want to know what 2 to the 4th power is. I get 16. Okay. All right. So it's getting kind of a little weird, but we're going to work back and forth. So this is a lot to take in today. All right. You give it a shot on these 3 here using those examples up above. Pause your video and then come on back. Okay, so let's see how you did. Again, I like method 1. So I put the 4 over for my root, and 3 is my exponent. So I took the 4th root of 16, which was 2, and then I cubed that to the 3rd power, not cubed it. All right. Took the 1 times 1 times 1 times 1, 5 times is still 1, and 1 to the 2nd power is 1. So that was kind of a weird one. Took the cube root of 27, which I knew was 3, and then I took it to the 4th power. So again, kind of the pattern here is this is my root, this is my exponent. Okay, that's kind of the power, or kind of what we're doing here. All right, let's do some word problems. My daughter, she kind of, when she graduated from high school, she was going into work in a zoo, and she worked with those orangutans is what it was over at Busch Gardens. And so she was doing, when you start working with these guys, which is really kind of hard to get into working with the zoo, a lot of people want to work with those animals. So it's pretty cool that she got accepted. But anyhow, the low man on the pole has to do all these math problems to figure out how many calories based on the animal's weight that they should feed them every day. And then they have to look at the food that they're feeding them and figure out how many calories are in an ounce and so forth and so forth. And so they use this formula for all of their animals. they said all animals kind of need this amount of calories. That is basically 72 times whatever their mass is, that's what M stands for, their weight, to the third fourth power. So she uses this formula every day because the weight of the animals changes periodically. Sometimes they gain weight and sometimes they lose weight. So they will test it like once a week, the weight, and then they'll recalculate how many calories this animal gets to keep them healthy. So in this particular case, it's a 16-pound or 16-kilogram dog. So that's the weight right here. That's our mass. So we're going to say C equals 72. I want to put a dot for times. They said the mass was 16 to the 3/4 power. So that really means 72 times, and I'm going to do it the way I like and the way Christina, my daughter, she does it this way too. Because I went to visit her and she was showing me, Dad, you really do use this formula. So what's the fourth root of 16? I think you'll start memorizing some of these guys here pretty quick. It's 2. So this amount right here is 2. I still have my exponent to the third power, so I'm going to do to 3. 2 to the third power is, that can't be right. 2 to the third power. I got back to 16, which is, I know wasn't right. So I got still 72 here. I'm going to bring that down. So really I got 72 times 8. So 72 times 8, 8's still in my calculator, so I'm just going to put times 72 is 576. Now again, new people, all word problems need word answers. You just can't put a box around 576 and say that's my answer. You have to answer the question. Find the number of calories a dog needs. So you would say a 16-kilogram dog needs 576. Make sure you put the units. What are these kilograms? Oh no, these are calories. We're measuring calories here, sorry. 576 calories. Come on, calculator. Per day. Now you need to say per day because that's what they asked up here. How much each day? Okay, that's what we call a unit rate that we learned earlier this year. So they would go to whatever the food is for the dog and look at how many, a cup is this many calories, which it says it on the package, and then they would weigh it out until they got 576 calories poured in the dog dish, and that's what the dog gets. They had pandas at the zoo there, and so same formula. Notice it's the same formula, 72m to the 34th. Okay, so in science and veterinarian and all those kind of occupations, you're going to use this formula. So the panda weighs 71 kilograms. So go ahead and plug that one in and do all your work. And let's see if we got a good answer. Okay. All right. I got an 81 kilogram panda needs 1,944 calories per day. That's a pretty good chunk compared to what was our answer up here, 576. So he burns a lot more calories a day. Man, that's a lot. It's like 3 times a dog. Yeah, he's probably quite a bit heavier than the dog, though. 72. I mean, how much was our dog? 16. Yeah, he's a lot heavier than our dog. Okay. This part right here, I think we're going to wait until tomorrow because we're on a Wednesday schedule today. And so we'll pick up on this part tomorrow. So on your homework today, do your practice sheet. You should be able to do all of those. Should be able to do all of those. The only part you need to stop on would be at 17. So from 17 on to 22, we'll do that tomorrow. But you should be able to still do 23. So do that one. And you should still be able to do 24. So do that one. And then tomorrow, we will work with these guys going in reverse order here. Looks like a crazy hard problem, doesn't it? Okay, so do that, and we'll attack that one tomorrow. Okay.